Hi, welcome to my YouTube channel or the Facebook page for Sensor Academy, depending on where you're watching me from. In our tutorial meant for today, we're going to create an exam build-up lesson, and by focusing on a 2022 GCE exam. The subject under discussion will be chemistry, and that categorically is supposed to be understood as science paper 2. We're going to talk about questions involving the periodic table. This can possibly be about bonding and formation of compounds. So in this question, we're going to use question 3, and that is from section B. It says atoms J and K have 8 and 12 electrons respectively. The first important thing to understand is that when you have electrons which are specified to be contained by a certain particular element, from that, firstly, you can make an electron configuration, and thereafter, from the electron configuration, you can tell the valence or the group where an element belongs to. So in this case, we have, that is atoms J is the first letter, which means its number of electrons is 8, and K is the last letter, which means 12 is its number of electrons. So let's see how we're going to do this. So here we have, that is J, so it has 8 electrons, and if we make an electron configuration, by the way, an electron configuration is a ratio of electrons that can be shown in the shells of an atom. So the first mandatory number that we need to put, that is in the first shell or subtract from the existing number of electrons, is 2. So I'm going to say 2, and then we're going to say comma. We can use a comma or we can use the ratios. So this is from 8, we've gotten a 2. The remainder is 6. As long as the number of electrons that are remaining is less than 8, you can write the number directly. So here we're going to say 2,6. And when we talk about K, K had, that is a 12, which means in the first shell we're going to say 2, and then 12 minus 2 is simply going to give us, that is a 10. From a 10 we can still subtract 8 and we'll remain with a 2. So those are the electron configuration, and by the way, an electron configuration is a ratio that will show the number of electrons present in each and every shell of an atom or an element. A. Determine the formula of compound or molecule formed by the combination of. So from the existing numbers, the last number of electrons is able to give us the exact group number where the particular mentioned element or letter containing electrons belongs to. In this case, that is atom J or element J belongs to group 6, whereas this one belongs to group 2. But the key thing about making a compound's formula is always about valences. By the way, a valence is a number, or this is the number of electrons an element can either gain or lose in order to be stable. So in this instance, we're going to find that this J has 6 electrons in its last shell. And every element to be stable in the periodic table needs maximum of 8 electrons to be stable, which means this 6 is not the valence, for we said the valence is either the number that can be gained or the number that can be lost as electrons for an element to attain a stable structure. So in this case, this J has, that is a valence of 2, because it can gain extra 2 electrons to be stable. And then this K has, that is a 2 at last, which means it can gain 6. But the number of electrons it can gain will take time and energy, which means this is its valence. So if an element has 1, 2, or 3 electrons in the last shell, that exactly should be assumed to be the valence. So determine the formula of the compound, the molecule, formed by a combination of J and K. We're going to say J has, that is a valence of 2. We're crossing it with K, and K also has a valence of 2. So if the numbers are even, you can reduce them. So I'm going to say 2 here, 1, 2 there, 1. So I'm going to cross multiply. So this is going to be J times K, which is going to give us, that is JK. So here we're going to say JK. Then 2, that is J and J. So in this case, if we are trying to use that is J and J, a very good example of an element on the periodic table that exists with 6 electrons in the last shell, or a configuration of 2,6 is oxygen. So in this case, if we assume J is an oxygen molecule, that will also probably depend if you are really good at understanding the periodic table. So if we talk about J and J in this case, this is going to be J. Since this can only gain and it combines with another element that can also gain, it means it's going to become a gas. So it's going to be J with a 2 here. So it's going to become J with a 2 here, which means this is going to become a diatomic gas. Then B. In each of the cases shown in A1 and A2, name the type of chemical bond that is formed. So in this case, in the first one, we are having this one, J, which is able to receive these 2 electrons to come here. So which means there is transfer of electrons from, that is, one element to another. This type of bonding is what we call ionic or electrovalent bonding. Then the bonding that occurs when the same element is able to bond within itself, that is going to be called covalent or molecular bonding. So in A1, we're going to say ionic bonding. Then in A2, we're going to say covalent bonding. Then C, give 2 physical properties of the compound formed in A1. When we talk about physical properties, we should understand that we are not going to talk about how it reacts or its chemical characteristic. So the first thing that is able to happen between 2 elements that can be able to ionically bond is that there will be transfer of electrons from one element or one atom to another. The second thing we're going to talk about is that the bond is between a metal and a non-metal, in the sense that an element that loses electrons to be stable would rather be called a metal, and an element that gains electrons in order to be stable would rather be called a non-metal. And also you can say the compound, when this is able to gain extra 2, it's going to become J2 minus. If this is able to lose these 2, it's going to be K2 plus. So which means the bond is made up of ions. So I'm going to say the compound is made up of ions. The compound is formed by transfer of electrons from one atom to another. Or we can say the compound is made of a metal and a non-metal, and by doing so, it means we've understood the concepts. So that means for the examiner to set a question in this way, it was everything about the periodic table, but then it involved formation of compounds as well as understanding valencies. There was actually no question about asking a group, but using the same very little information that I laid in the first place, I hope you can find it beneficial to grasp the concept, and at the end, at least try to build on self-reliance and self-dependence as you are trying to prepare adequately for an exam. Make sure you subscribe to this YouTube channel. Make sure that you invite, you share, that others may also find the same video and at least help them create on that is self-dependence and build on self-reliance, because at the end of the day, the main idea of all this is to ensure that you, once you find this video very much beneficial, at least you are able to emerge victoriously over this year's final exam. If you're watching this on my Facebook page, also kindly share the page, tag others that are writing an exam for this particular year, in order for them also to see to it that this video is very much highly beneficial. And for now, stay focused and stay determined. Make sure you focus on the areas where you're good at in order at least to avoid negativity. Make sure you sharpen and polish up with some of the topics you are liable to use in order to prepare for an exam. This has been your tutor, Mr. Sensor from Sensor Academy School of Tuitions. For now, till in the next video, it's a very good bye.